Four major tech companies are expected to spend $650 billion on new infrastructure in 2026 alone. To grasp that scale, stacking it in $100 bills would rise over 700 kilometers, clearing the altitude of the International Space Station. That massive influx of capital has triggered an intense physical buildout. A decade ago, the United States had essentially zero dedicated AI data centers. Today, there are over 4,000 of them. Wall Street has treated this ongoing expansion as a total certainty. But on the ground, nearly half of the data center projects slated to open in the US this year have already been delayed or canceled outright. Take Microsoft, for example. You can read the slick press releases about their upcoming facilities, but satellite imagery reveals that none of the data centers they announced and broke ground on since 2023 have actually been completed. Entire mega projects are failing before a single server is plugged in. In Texas, an ambitious 17-gigawatt AI campus saw its CEO and CFO resigned back-to-back, while its market cap collapsed from $20 billion down to less than $4 billion, all without breaking ground. Maintaining the digital cloud requires an immense physical footprint. It consumes vast stretches of land, tons of heavy steel, and millions of gallons of water, and the physical world is finally pushing back against those requirements. To understand why the build-out is stalling, you have to look at the hardware. Training modern AI models require specialized racks of GPUs, and these components draw significantly more power than any traditional server array that came before them. Powering these racks requires massive industrial electrical components, like these heavy-duty transformers. But there is a severe global shortage of this essential switchgear, the majority of which is imported from China. As geopolitical tensions disrupt supply chains, these orders are becoming increasingly unreliable. The delays aren't isolated to hardware. The skilled labor pool is completely tapped out. Meta is currently struggling to hire fiber technicians fast enough, forcing the company to start training new workers from scratch just to keep their projects moving. Then there is the sheer volume of electricity required. Meta is currently building a sprawling data center in Louisiana, projected to draw around 5 gigawatts of power. That single facility will consume roughly the same average electricity as the entire city of London. Running that much electricity generates immense heat, and the current solution for cooling these facilities relies heavily on water. A single large-scale AI data center can run through up to 2 million gallons of water every single day. To keep the cooling systems from corroding, operators add chemicals like PFAS, often known as forever chemicals, into the pipeline. These chemical additives prevent metals from breaking down, but they also cannot be removed when that wastewater is eventually sent back to local municipal treatment plants. The companies driving this build-out constructed their business models on the assumption of infinite grid capacity, endless water supplies, and perfectly reliable supply chains. Those assumptions are now collapsing under the weight of their own physical footprint. When supply chains and power grids are strained, the hidden costs don't fall on the shareholders. They are absorbed almost entirely by the local communities surrounding these projects. Living next to an AI data center means dealing with a persistent, low-frequency drone from the industrial cooling fans. In Virginia, residents report the noise vibrating right through their walls, with some homeowners spending up to $200,000 on specialty insulation and new windows just to get a good night's sleep. And the financial burden often lands right on their kitchen tables. Down in Georgia, the intense grid demand created by nearby tech facilities prompted the local power utility to raise consumer rates 6 times between 2023 and 2025, a massive 24% spike. The tech firms usually secure heavily discounted property taxes by promising an economic boom, but the numbers rarely add up. In Oregon, local schools lost an estimated $275 million in potential revenue due to tax abatements. Meanwhile, even the largest of these hyperscale facilities typically employ fewer than 150 permanent workers. People have simply had enough. Across the country, community-driven project cancellations quadrupled in just 1 year. State legislatures are stepping in. Maine became the first U.S. state to pass a sweeping ban on new data centers until 2027. The pushback has escalated so rapidly that the federal government is closely monitoring the situation. U.S. law enforcement and the FBI have officially classified AI sentiment as an emerging domestic threat, warning that community protests could devolve into violent extremism. The rapid build-out is meeting a new era of localized friction. In states where these projects were once heralded as digital infrastructure hubs, developers are now navigating a landscape of legislative bans, mounting lawsuits, and a public that is increasingly unwilling to subsidize the bill. All of this physical friction is now bleeding over into the financial markets. The major players have burned through their own cash reserves and are increasingly relying on private bonds to fund construction. To attract investors, some of these bonds are paying 8 to 12% interest, which strongly implies a junk bond level of risk. This chart shows the massive outbound flow of capital expenditure required to build these centers. But look at the incoming revenue side. Many companies take immense business risk building mega projects on speculation without a confirmed anchor tenant. And even ignoring financial risk, physical blockades create a hard ceiling on growth. You literally cannot plug it into the wall. This gridlock is forcing the industry to rethink its approach entirely. In China, operators deploy subsea data centers, shipping container capsules dropped to the ocean floor. They use the naturally freezing seawater for passive cooling, allowing 99% of the electricity to go directly toward computing. Then there's the software alternative. We are seeing a rapid rise in a highly efficient open-source AI models that don't need a billion-dollar data center. They run completely locally on everyday consumer laptops, satisfying most users' needs without drawing on a massive centralized grid. We are watching a trillion-dollar industry collide with the limits of reality. The future of this technology won't belong to the companies with the most capital to burn, but to those who can figure out how to integrate their innovations into our physical world without destroying it in the process.